Hi everybody. Today we're going to take a look at what the sine and cosine graphs look like. So let's first start by labeling some points on my unit circle. Now you all know that if you start right here, that's considered to be 0 radians. Now if you go up to this point right here, that's going to be half of a pi radians, which we like to call pi over 2. If you go halfway around the circle, that's pi radians. If you go 3/4 of the way around the circle, that's 3 pi over 2 radians, or 1 1/2 radians. And then back at the start again is 2 pi radians. Now, of course, you could keep going around and around the circle. So, for example, after 2 pi, you could say 5 pi over 2. Back up here again, and so on and so forth. Now, if I label those points of intersection, there's the point 1, 0, 0, 1 is up here, -1, 0, 0, -1. Now, you've learned in the past before in other chapters that every point of intersection on this circle is cosine of the angle, sine of the angle. That means that the x value goes with cosine and the y value goes with sine. So what I'm going to do on these graphs here is I'm actually going to graph the sine and cosine functions. So I'm going to call the x-axis theta, and we're going to do sine first, so I'm going to call the y-axis sine of theta. So what I'm going to do is I'm going to actually label this x-axis just like I labeled around the circle. So the origin's going to be 0. The next tick mark is going to be pi over 2, then pi, then 3 pi over 2, and then 2 pi. Now if I look at this circle, if I look right here at 0 radians, the y value of the point is 0. That means that the sine of 0 is 0. So I'm going to plot a point here at 0, 0. Now if I evaluate the sine of pi over 2, that means that I'm going to look at the angle at pi over 2, which is right up at the top there, and I'm going to take a look at that y value. Now that y value at pi over 2 is 1. So that means that the sine of pi over 2, everybody, is 1. So I'm going to mark a point at pi over 2, 1. What do you think the sine of pi is? Take a look at that circle. Can you tell me what the sine of pi is? That's right, it's 0. The sine of pi is 0. Very good, because the angle pi is right here, and the y value at that point is 0. Okay, so I'm going to plot a point at pi, 0. The sine of 3 pi over 2 is -1. You're absolutely correct, because 3 pi over 2 is right down there, 3/4 of the way around the circle, and that y value at that point right there, that y value is -1. So I'm going to plot the point 3 pi over 2, -1. I'll label that right there. And then lastly, the sine of 2 pi is going to be the same as the sine of 0, and that should make sense to you because 2 pi radians and 0 radians land at the same spot on the circle. So now I've got this pretty curve here. I'm going to draw this curve right through these points, and that looks fantastic. Now the cool part is that you could keep going around and around and around the circle to continuously make this curve over and over and over again. Just keep making that curve. What I'm going to do is I'm actually going to draw the curve again on the left-hand side, because you could go back around the circle the other way. And this sine curve just keeps repeating this really pretty wave over and over and over again. Okay, so let's see if we can get a good picture of the cosine curve. So again, I'm going to label this theta, and I'm going to label the y-axis cosine of theta. And I'm going to just quickly label these tick marks just like I did around the circle, because our curve is really modeling the x values that are happening around the circle. So the first thing I'm going to say is, what is the cosine of 0 radians? So again, I'm back here right at the beginning. I'm going to take a look at that point, and that cosine of 0 is 1. Because now what I'm doing is I'm looking at all of the x values at every special angle. I'm looking at all of those x values, okay? So now let's take a look at the cosine of pi over 2. If I go up to the angle pi over 2, then the x value at that point is 0. So the cosine of pi over 2, everybody, is 0. Okay, now what about the cosine of pi? Take a look at that angle pi, it's right here, and tell me the x value at that point. Very good, the x value at that point is -1, so I'm going to plot pi -1 here. Just label that. What about the cosine of 3 pi over 2? Cosine of 3 pi over 2. Remember, 3 pi over 2 is 3/4 of the way around the circle. And here we are, the cosine is 0. Very good. And then, of course, the cosine of 2 pi should be the same as the cosine of 0, because 0 radians and 2 pi radians is at the same place. And now I've got this curve here. This nice cosine curve, okay? And I'm just going to draw it on the other side as well, because we know that we can just keep having this curve happen over and over and over again as I go around and around and around the circle, okay? Now, the sine and cosine curves are very important curves, and we're going to take a look at a lot of different types of them throughout this next unit. And the most important thing about them is the fact that they continuously repeat over and over and over again. Okay, they are called periodic functions. Now, a periodic function is a function that has repeating y values in regular intervals. So if you can see these y values continue to repeat on both the sine and cosine curve, and it happens in these regular intervals, okay? Now, they happen in a very specific amount of time. So if you take a look, in each of these curves, in each of these cycles, they start to repeat every 2 pi radians. Okay, now that should make sense to you, because as you go around the circle once, you are going around 2 pi radians. And as you go around again, the cycle repeats. And again, the cycle repeats. Okay? So the length of one cycle is what we call the period. The period of a periodic function is the length of one cycle. And in this case, both periods are 2 pi for both sine and cosine. So I'm just going to put right here that the period is 2 pi. And the period here is 2 pi, okay? So we've got a periodic function that has repeating y values in regular intervals, and we've got a period, which is the length of one cycle. The other important piece is what we call the amplitude, okay? Now, the amplitude is half of the total vertical distance, and it's also related to what we call the midline. So it's half the total vertical distance, and it's also the distance to and from the midline. Now, if the amplitude represents half the total vertical distance, and it also represents the distance to and from the midline, then it should make sense to you that the midline is a horizontal line that cuts the graph in half. Okay, so I'm just going to put that right here. The midline is a horizontal line that cuts the graph in half. So if I were to draw that in, In our case, the midline is just going to be right on that x-axis. The midline is just going to be right on that x-axis because you can see now that the amplitude in both of these cases, for both sine and cosine, is going to be 1. Because that graph has a midline right on the x-axis, and the maximum is 1, whilst the minimum is -1. Max at 1, minimum of -1. Okay, so that amplitude is 1 because the distance from the midline up is 1 and the distance from the midline down is also 1. Okay, guys, so these are just very important concepts to understand and definitions to make sure that you have written down. And we're going to do some examples in the next video of how to find the period, the amplitude, and the midline. Thanks, everybody.